Welcome back, YouTube. Today we're going to talk about obfuscation techniques and principles part 2. So if you remember, in the previous video we talked about part 1. We discussed obfuscation techniques, we discussed principles, and also we talked about how to use that for signature evasion. We also talked about that one of the important uses or use cases of obfuscation is to protect intellectual property of a software. Although we are not concerned about protecting intellectual property or trademarks of a specific software, it's good to know that one of the most, or originally, obfuscation has been created for that purpose. Now, our concern or our objective is to explain obfuscation from the perspective of signature evasion. So we talked about concatenation. Also, we talked about the taxonomy layer, where we discussed the several techniques of obfuscation. In the last video, or in this video, we focused on concatenation or obfuscating data as a way of, obfuscating the code. Now, today we will talk about the part 2. We will discuss other obfuscation techniques. Let's go back now to the PDF that we have discussed in the previous task. So basically, as you can see, in the last video we talked about obfuscating data. We discussed the sub-techniques that go under obfuscating data. Namely, we discussed array transformation, encoding, and splitting, merging. So today we're going to talk about obfuscating the layout and obfuscating controls. Now, although obfuscating data is good for hiding the intent of the code, sometimes we may need to add additional protection on the code. Okay, for example, we may need to use obfuscating controls or obfuscating layout. So in today's video, we're going to discuss first obfuscating layout and obfuscating controls. These two layers are good if you want to not only evade signature, the antivirus signature, but also human analysis. So basically, if we go to obfuscating layout, we have here the junk code. Junk code means sometimes we add junk instructions that are non-functional. Can be called also as code stubs. We have here separation of related codes. This is also another technique where we separate related codes or instructions to increase the difficulty in reading the program. Stripping redundant symbols. Here we strip symbolic information such as debug information or other symbol tables. And lastly, meaningless identifiers. In here we transform meaningful identifier to something meaningless. So it's like playing with the objects, variables inside the code to make it so hard for analysis. As you can see, all of them are explained here. You can go over the documents and get more details about every technique under every layer. Obfuscating controls, here we have implicit controls, dispatcher-based controls, probabilistic control flows, and bogus control flows. Here we talk about, here in this layer, guys, obfuscating controls, we mainly manipulate control flow or the logic of the code. What do you mean by the logic of the code? So basically, the control flow is a critical component actually of a program's execution that will define how a program will logically proceed. So if you remember, guys, we have the logic loops. Let's go back to the board. So the control flow is controlled by the logic of the code. So some logic statements that control the flow of the program, such as if, else. Also we have try, catch, switch, case. Also we have for, while. These are all logic statements that control the flow of the program. If we want to obfuscate the code of course, under this layer, obfuscating controls, we may manipulate the control flow of the program by manipulating these logic statements. For example, try catch here. So try catch will try to execute a specific code block and catch it if it fails to handle errors. That's how it works. And of course, I am sure you know, guys, how if else works, switch, and for a while. So let's now take an example of how control flow is manipulated in a code. So if we get back to the paper here, guys, see, we have the probabilistic control flows and we have the bogus control flows under obfuscating controls. These can be used actually to arbitrarily add logic to a program or refactor the control flow of a pre-existing code. So if you want to use these two methods, we can fall back to something called the opaque predicates. So what are opaque predicates? So basically opaque predicates used to control a known output and input. Okay, now let me show you this document here. So according to that document that will show up in a minute, opaque predicate is actually a predicate, right, whose value is known to the obfuscator but difficult to deduce by the analysts. It can be seamlessly applied to other obfuscation methods. For example, here if we go back to the other documents, we have the obfuscating layout, we have junk code. Opaque predicates can be also applied or combined with junk code to turn reverse engineering attempts into arduous work. So opaque predicates, guys, fall under obfuscating controls, specifically bogus controls and probabilistic control flows. They are used to manipulate the control flow of a program. Specifically, we have another method actually. If you go back here, it's called the Collatz conjecture. So Collatz conjecture is a mathematical method, guys, by the way. Common mathematical problem that can be used as an example of opaque predicates. So it's not fully required for me to understand Collatz conjecture, but it's actually enough to say that you need to know or understand the principle of Collatz conjecture in order to work with opaque predicates. Opaque predicates, we will see an example how we can use that in a code. So let's go now to the task and analyze this code. So let's take a look at this code. So what's required here? Using the knowledge you have accrued throughout this task, you put yourself in the shoes of an analyst and attempt to decode the original function and output of the code snippet below. If you correctly follow the print statements, it will result in a flag you can submit. So basically, guys, this code is an example of showing the control flow of a program. As you can see in this code, the control flow is actually maintained by the while statement. While, if, and else. Also we have for. So basically these logic statements control the flow of the program. Now let's take a look here, guys, and understand this logic of this code to be able to reduce the output. Okay, so we have here variables x, swvar, a, b, i, case 1, case 2 until case 6. So while x is more than 1, okay, we go into this if statement. If not, then we're going to execute this statement. Okay, and then under the while loop here we execute another if statement, okay, that says if x equal to 1, we enter into a for loop here, where for each case of these we perform specific actions. Okay, let's take an example, guys. I'm going to show you an example and the rest is so easy. So the value of x here is equal to 3, right? Okay, so when we enter the while loop here, we make sure that x is more than 3, which is actually it's more than 1, sorry, which is 3. So basically we enter the while loop here, we perform the if statement. Okay, now when if doesn't work, we perform the else. So if will not be executed because actually the remainder of x over 2 is not equal to 1, so we go here. So x equals 3 over 1, which results in 1. So when x equal to 1, we will enter the if statement here, where it will execute the for loop. So let's go over the for loop here, guys, and understand how we can extract the flag from this. So match swvar. So swvar is a variable used to control the way we jump between every case. So swvar here equals to 1. So when it says match swvar 1, match swvar, it means it's going to look at the value of swvar, and according to the value it's going to jump to the case number accordingly. So since swvar equal to 1, it's going to go to case 1. So print case 1 index I. I here equal to, supposed to be equal to 0 here. This is the counter, okay? Now case underscore 1 0, it will go to the first element of the array case underscore 1, which is t. Now here, this is the first letter of the flag, t, as you can see here, okay? Now then we have the assignment of 2 to a and b, the assignment of this value to b, and now SW_var equal to 2. So when SW_var changes to 2, we're going to jump to case 2 here, okay? Now we go to case 2, print case underscore 2 I. So we access, as you can see here guys, the next element, no, the counter I after we exit case 1, okay, it will be increased by 1 according to this, okay? Now when I equal to 1, we're going to the next element or the second element of case underscore 2, which is h here. So it's going to print h. Now so far we have t and we have h, as you can see here, th. Alright, next we have an if statement. If a is more than 10, which is not, because a equal 2, then we will not execute or will assign 6 to SW_var. We're going to execute the else. Else SW_var equal to 3, which means we're going to jump to case 3 after increasing I by 1. So now I equal to 2. Print case underscore 3 I. So I here equals to 2, which means we're going to access the third element of case underscore 3, 0, 1, 2. This is the third element. Now we have the beginning of the flag, THM. Okay. Alright. So b equal b plus a, b equal to this number, okay, a equal to 2, so which means we're going to increase this number by 2 and assign it to b. Fine. Now if p less than 10, which is not, this means it's going to execute this assignment here. So SW_var equal to 4 and we'll jump to case 4. So don't forget that I here equals to or has become 3. So we're going to access the fourth element of case underscore 3, 0, 1, 2, 3. So this is the fourth element and this is the beginning of the braces. Easy, right guys? So here b equal b plus a, no, case 4 here, we are here. So case 4, we printed the fourth element, and then b equal b minus b. So here b equal to, b equal b minus 1. So b's value here we will decrease by 1, and then we jump to case 5. So case 5 here we increase I by 1, which has become 4. So we access now the fifth element of case 5, 0, 1, 2, 3, 4. We have d. Okay. Now next, a equal a plus 1. So now let's go back to a value. So a here is equal to 2. It's gonna become 3. Now a equal to 3 here, and now we're gonna get back to case 2. We jump back to case 2 here. Don't forget to increase the I by 1, which has become 5. So now I equals to 5. Now we go to the sixth element of case 2, 0, 1, 2, 3, 4, 5. And here we have 3. And guys, you carry over the rest and you will be able to deduce the flag. That's an example of how you can understand the code flow of a program and how logic statements can be used to control the logic flow or the control flow. Okay. Alright, now let's get back to the board here. Okay guys, so far we talked about obfuscating controls and we talked about how we can use or how we can manipulate the code flow of a program and to understand what are the things that control or understand the logic statements that control the code flow. Now we're going to discuss obfuscating layout and how we can use these sub techniques as part of obfuscating layout and what we are trying to protect in here. So if you go back here to the board guys, our concern is to protect always the identifiable information in a software, whether for the purpose of protecting intellectual property or for the purpose of obfuscation. So basically here we're looking to protect three things. First, code structure. If you protect the code structure, we can prevent the analysts from understanding what's going on, right? The next thing, object names. Very important if you want to protect it from signature, antivirus signatures. And 3, the file /compilation properties. Prop, and I'm going to put S here, properties. Okay, first let's talk about object names. So we're going here to discuss how we can obfuscate object names. So guys, object names is actually very important in a code, right? In order to understand the code, you have to understand the object names, variable names, right? Arguments. So it's one of the most significant insight into a program's functionality and can reveal the exact purpose of a function. So basically, object names can differ between a compiled or interpreted language. So here we have two parts. We have the compiled, okay, or interpreted language. So object names differ between these two. So what do you mean by saying interpreted language? Interpreted language, such as say Python, it needs an interpreter, right? So interpreted language such as Python, or we have also PowerShell. So in the case of Python or PowerShell, all objects matter and must be modified while you are doing obfuscation. So here you have to change all of the objects, or to obfuscate all of the objects in the case of Python or PowerShell, because they matter, right? But if it was a compiled language such as C is a compiled language. C# is a compiled language. So here the important objects to obfuscate are only the objects appearing in the strings. These are the only ones that are generally significant. Now an object may appear in the strings by any function that produces an input-output operation. So we only care about objects in strings. Objects in strings. These are the objects important in compiled language. We have to obfuscate or focus on obfuscating these objects. But in interpreted language such as Python and PowerShell, here all objects matter. All of them have to be obfuscated. Okay. Let's now take an example code here, guys, from the room. Let's take a look at this one. So as you can see, this is a code from a compiled language, right? So we have these variables: process handle, remote thread, remote buffer, and we have also this variable string leaked. This was leaked in the string, and now here we're looking to obfuscate this code. So obfuscate the objects in this code. So in order to obfuscate the objects in this code, we have to change the names of these objects so that they become meaningless. Here we are actually in the layer of meaningless identifier. So if we go back to this one, this paper, as you can see in obfuscating layout, we have junk code and we have meaningless identifiers. We are in this layer here, guys. So we're looking here to make these variables meaningless identifiers. Again, we're going to remove this one. Basically, what we are attempting here, guys, is to make the output of the strings function or the strings tool, right, to be something that an analyst cannot understand. So basically here, as you can see, they used strings on the program whose code is here. As you can see, they were able to produce all of this output about it. Okay, now after obfuscation, as you can see, they have changed the names of the variables and they removed the string from here, this variable. Okay, as you can see, the objects that appear in the strings have changed, just as here. So when they have renamed the objects or the variables, they also have renamed them in these assignments over here, and also they have removed the print statements, the cout. Okay, that's very important in making the object names meaningless identifiers, and that's part of obfuscating layout. So basically we are obfuscating the objects here. Now there is another code, guys, in PowerShell. This case, PowerShell is interpreted language. So all the objects, all the variables are important in the obfuscation. Okay, so I know sometimes the code is so long, so there is another tool they used, which is strip here, to strip all the important elements from the code. That's in the case of interpreted language, and also it can be used for non-interpreted language. Take an example, this code here. It is actually similar to the last one. So this code, we're going to obfuscate the variables, and we're going also to apply, or we're going to use the strip tool to strip all the important information from it, so that the code becomes obfuscated and hard to analyze. And this is part of the last task, by the way. So let's do that. So we take the code, and what we're going to do here, we're going to split or start the attack box. Okay, so while the attack box is starting, let's talk now about, so we talked about object names, let's now talk about code structure. So basically in code structure, in order to obfuscate the code structure, what we have to do here, we have to go back to obfuscating layout, and we add junk code. Okay, so adding junk code is actually a measure, or can count as additional measure to add complexity to an interpreted program. So again, we add the junk code here to the program before it is compiled, in case we're talking about compiled language such as C or C#. So here the code structure can be obfuscated using junk code. Okay, junk code should be added before compilation. Now, in case of interpreted language, it can also add complexity to an interpreted language, such as Python or PowerShell. So basically, why it adds more complexity in the case of interpreted language? Because the program isn't compiled, so an analyst, sometimes has much greater insight into the program. Alright, so the last one here we have file and compilation properties. So basically, guys, more minor aspects of a compiled binary, such as the compilation method, may not seem like a critical component, but actually the compilation method you choose while you are compiling the code can lead to several advantages to assist malware analysts in analyzing your code. So for example, we have many modes of compiling a program. So we have the debug mode. Okay, now if a program is compiled as a debug build, or build, let me say, call it here. Okay, analysts can obtain all the available global variables and other program information. Okay, also all the symbols can be revealed. So what we're looking to do here, guys, we have to change the compilation mode. Okay, so instead of debug mode or debug build, we choose to something called release. The release build. When you're compiling your program, make sure you choose release build. Okay, now release build, what we do here, guys, we remove all the critical components that would identify or help the analyst analyze the code. For example, simple or simple files are easily removed through the compiler or after compilation. So to remove these symbols, for example, we choose the release build. So make sure you choose release build if you're looking to obfuscate your code or obfuscate the file compilation properties part of your code. Now let's go to, so the attacker machine has started. Okay, now let me copy the codes from the task. Okay, start a new terminal from here. Zoom in, zoom in, zoom in. Alright, so we're going to say nano challenge 8 in C. I'm going to paste this code. So what are the things that we would like to change in here, guys? The first thing that we will change here is the variable names. We will going to change the process handle name, the variable name here, this one, remote buffer. We're going to remove this. Okay, now once we change the variable names here, we're going to reflect on that by changing also the occurrences of these variables here. This one will be changed. Okay, now we remove all the couts. All the couts, they would give, actually couts give meaningful information to an attacker. So part of adding meaningless identifiers as an obfuscating method, we remove the couts, all of them. Okay, and that's what we need to do, guys. Just remove the couts, change the names here, and reflect on the changes here by changing the occurrences of the variables, also inside the calls here, and also remove cout leaked. So this is it. Now let's see how the code changes when we remove all of these. So I'm not going to save this one. I'm going to open a new one and paste the obfuscated version. As you can see, we changed the names here, and we reflected on that by changing the occurrences of these variables here. You remove the couts, and this is it. So let's save that. Alright, so now let's compile the code using this tool, -o challenge 8. And now it's time to use strip, guys, to remove all the redundant symbols from the code. If you go back here, so as you can see, you're stripping redundant symbols, part of obfuscating layout. Okay, going back, it's going to strip -strip -all challenge. Okay, now what we're going to do, guys, we're going to upload the file. Okay, ls. Okay, this binary, we're going to upload this binary to the machine web page, and if our work is correct, we're going to extract the flag. And this is the flag. So that's how you solve the last task, guys. I hope you liked this room, and I hope you learned something about obfuscation. So basically, this was an introduction to obfuscation principles and techniques. Now, I know that we haven't covered all of the obfuscation techniques. We have covered just maybe some of them, but the room after this that we should go over, it's called the signature evasion. We're going to put all of these principles we learned into practice. So basically, we're going to, let's see here, signature evasion. So everything we learned about obfuscation principles will be put in practice here to apply it on real scenarios in evading antivirus signatures. So stay tuned and see you in the next video.